Hey everybody, today we're going to be doing a kind of interesting video. We've done the derivative of n functions, we've done several types of videos on that, the chain rule on n functions, all that sort of stuff, but we haven't really gotten into nth derivatives yet, that much in this channel. We've done a couple of short little videos, but nothing like this. Today we're going to be looking at the nth derivative of the product of just two functions, right? We can go into multiple functions later, but right now we're just dealing with two functions. And so we're basically taking the nth derivative of a product of just two functions. And so this will involve a few different ideas. So hopefully you're comfortable with calculus, algebra, all that kind of stuff, because we'll be using a lot of different concepts today. So let's just get started. This is kind of how anyone would probably just start approaching this question. Look for a pattern, right? So we can just basically start by, recalling the power rule. I hope you guys are familiar with the power rule before delving into this video. Product rule. Basically, we can just start by taking the derivative, the first derivative, and I'm just going to denote that with these parentheses. This is pretty standard notation when you're dealing with higher order derivatives. So we're taking the product of two functions. I'm going to omit f of x, g of x. I'm just going to say f and g because we know what we're talking about and it saves a lot of space, especially when we have to do these a lot of times. So the first derivative, we know that this is just going to be f prime times g plus f g prime, right? Once we do that, we can then find the second derivative, so that's denoted with this 2 in parentheses. And what this is going to be is basically just the derivative of this. So we're just essentially taking more and more derivatives of this guy, right? And so what we can do is start by saying, let's just focus on this first term. So it's going to be, we can take the derivative of the first, so it's f double prime times g plus f prime times g prime. Okay, I hope you see how I did that. We're going to be doing this multiple times. So then we're going to be adding this to f prime g prime plus, so we're focusing on this one, so f prime g prime plus f g double prime. And I hope you kind of see a little bit of a pattern here. We have the f double prime here multiplied by no derivative of this second function. Meanwhile, we have no derivative of this first function multiplied by g double prime. And then in the middle, notice how this is just 2 of the same thing. So I'm just going to get rid of this, and I'll just say plus 2 of that. So plus 2. We'll see more of these patterns and more complicated simplifications, but for now, we'll just leave it like that. So this is kind of an interesting pattern. Hopefully you kind of see where this is coming from, and stuff like this will continue. So let's see what happens next. Then we have fg to the third derivative, and so now we're going to start by taking the derivative of this term here. So again, product rule. So f triple prime, and I will actually start to I'll start to use the notation here. So so we have f, the third derivative of f, times g plus okay, so again, we still have the same sort of pattern. Third derivative, zero derivative, third derivative. In the middle, we have this and this, which are again switched around, and then we have these, which again are sort of switched around. Let's see, I don't think we have any duplicates here, because this is second derivative. Oh, okay, we do. So this term and this term are the same, and then this term and this term are the same, just different coefficients. So let's condense this. So we have 2 plus 1, so that's 3. So I'm just going to replace this with a 3. Okay, so just don't mind the gap there, or do mind the gap. And then again here we have 2 plus 1, so then again that's just going to be 3. So I'm just going to do that. I'll just put the plus in the middle here just to, there we go. Looks like a multiplication. Okay, so, yeah, so now we have this 1, 3, 3, 1 sort of thing here. So we had 1, 1 basically, then 1, 2, 1, 1, 3, 3, 1. If you're seeing the pattern, then that's great. I don't expect a lot of you to see the pattern, but we'll see, we'll see. Okay, so let's go to the fourth derivative now. Okay, let's condense everything again. So again, we have this term and this term, which are basically opposites. And then we can start to, and then everything else is opposites. I'm not going to go into that. Okay, so I put everything into one line, so we have f4g, yeah, f4g 0 basically, plus 4 f3g1, plus 6 f2g2, plus 4 f1g3, plus fg to the fourth. Okay, so let's look at the patterns sort of here, what's going on. So notice how f, the derivative of f starts descending, so we have 4, 3, 2, 1, and then 0, basically, the 0th derivative. On the other hand, the derivative of g increases. So we start with 0, then we go to 1, 2, 3, 4. So that's a really easy assumption, or not assumption, of observation. So we can start with that. So we get fg to the n, so the nth derivative. It's going to be some sort of sum because we're adding up a bunch of things. And I'm going to start at k equals, we'll hold off on that. There will be a coefficient. We'll talk about the coefficient later, so I'm going to leave this space blank. So we have f, and k, so if k starts at, well, it'll start at 0, and it should kind of make sense why, and we'll go up to n. So f to the, we're going to do n minus k derivative, right? So in this case, so it's going to be n minus 0, that's just n, so f to the n, so the nth derivative, so 4, 4, makes sense, so n, and then that's going to be n minus 0, so hopefully you see how that makes sense there. And then we're also going to be multiplying by g just to the kth derivative here, because we're starting at 0, then 1, then 2, then 3, then 4. So this n minus k, what it does is it kind of takes, this and kind of it subtracts it from the most, so it's like most minus that, and so you're going in the opposite direction. So this increases all from 0 to the last number, and then this n minus k decreases, starting from the top all the way down to 0. So hopefully that makes sense. So that explains the main part. But what about the coefficients? Notice how we started with 1, 1. This is kind of a weird one, though. I don't really want to go into that. But then we have 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Does that ring a bell? Well, if I have Pascal's triangle, if you guys know that, then that should. So we start, I think the way it goes is 1, then 1, 1, and then 1. So the process here is you're taking, you're increasing the number of like cells here. So there's 1 cell in this row, 2, and then here there will be 3. There's 1, 2, 3, and you're adding like 2 here. So like 1 plus 1 gives you 2, and then here 1 just is 1, and then 2 plus 1 is 3. 2 plus 1 again is 3. And then you have 1, 1. Okay, 3 plus 3 is 6. 3 plus 1 is 4. 3 plus 1 is 4, and then 1, 1, and it keeps going. We can do one more. 6 plus 4 is 10, 6 plus 4 again is 10, 4 plus 1 is 5, 4 plus 1 here is 5, and then 1 and 1. So it just keeps going like that, right? And so yeah, here, the only difference is this is like the 0th row, and then 1st, 2nd, 3rd, 4th, 5th, and so on. So notice here we have 1, 1. So I guess FG to the 0 we can do as like a trivial case. That's just going to be FG. So it's 1. So it's one of them. So it's basically that, right? And then here we have 1, 1, then 1, 2, 1, 1, 3, 3, 1, which is that, 1, 4, 6, 4, 1, which is here, and then I didn't show the 10 or like the last row there. But yeah, so it just keeps going. That triangle goes on forever. And so these are the binomial coefficients, if you're familiar with that. And basically, we have this notation, basically just n choose k. It's not a fraction. It almost looks like a fraction if you just drew a little fraction bar there, but it's just n choose k. And there's a whole, like, there's a lot more that you can learn about this. But if you have a little understanding of what's going on here, I think that's good enough. So these coefficients come from basically this triangle, and this is pretty much it. So our formula that we found was this, right? And I believe, yeah, you can totally do an induction on this to actually prove that this is true. But anyway, that was a lot, so I hope you enjoyed. I hope you understood everything. If you do have questions, let me know, and I will see you guys in the next video. Bye!